Okay, today is SIG Instrumentation meeting of June 25th. Frederick, you were saying?
I was just going to ask David if he could give us a quick follow-up from the discussion that we had last time, where he was going to go to SIG Node and ask about the additional metadata in log paths, I believe.
Yep, so you can hear me, right? So I brought it up. There were two. I have to refresh myself. I'm reading my comment. So there are two concerns that came up, which I think were the reasons that they didn't do this in the initial version of the CRI log format. But one being that there's some limitations with how much stuff you can stick in a file path, and so there were concerns that we may not be able to add it directly to the path for the file. The second concern being scalability, just because we would have to watch namespace objects from all the nodes. So yeah, that was the feedback. It probably would require a KEP and some experimentation to figure out if the former is a concern, and then whoever did it would probably have to work with SIG scalability to make sure that any new watches that we're adding on namespaces don't cause any regressions.
So I'm not sure we're actually the right group to discuss this necessarily, but we have Han from SIG API machinery. I wonder how this is not a problem with basically any resource, right? Like anything that's namespaced, the namespace may be deleted and quickly recreated, or like maybe there's just some external thing that doesn't necessarily watch, right? Just it could be an entirely new namespace, right? Like it seems unreasonable to do this, but like an obvious solution to this could be let's add it to object meta, right? Like it's probably not going to happen because that would probably be too huge of an impact to literally any object in Kubernetes. But like, am I mistaken that this seems to be a problem for literally anything?
Wait, what is the problem that you're describing?
So the issue describes how log metadata essentially lacks not just, it has the namespace name, but it doesn't have the namespace UID. And so there can be certain situations where like recreating this namespace may actually cause like a separate namespace to exist, but it happens to collide with the name, right? The UID is different, but
yeah, but that thing is kind of broken right now anyway, right? I mean, like, I've definitely seen orphaned objects under namespace where basically in order to clean them up, like if garbage collection failed or whatever, you basically have to recreate the namespace. So you're going to have a different UID, but it's effectively the same.
I think.
Right, but the point was like people want to know that it's the new namespace.
I mean, yeah, so we don't really have this problem in API machinery because we don't really ever care about the UID of the namespace. Like, I fail to see in which circumstance that matters.
I think the guarantee we give is that a namespace name is unique at any given point in time, but not across time. And so right now for metrics, for example, we stick with namespace name because any particular metric is pointing at one namespace, right? But if you
at most one.
But I guess the issue is that for log storage, for whatever reason, like some people have problems with or want to make sure that a namespace can't be recreated and then the same information is queryable. I guess
Well, it's broken then, because that assumption is actually incorrect. Like, people actually do create this namespace to do garbage collection properly sometimes. So.
But you cannot like delete namespace without breaking like the lifetime of pod. You need to delete all the objects in namespace.
Well, I mean, you have garbage collection, but sometimes garbage collection fails or gets stuck for some reason. You have orphaned objects under a namespace, and it becomes like impossible to clean them up unless you actually recreate the namespace or do
so
whatever.
Could the pod migrate between namespaces? What I mean here is garbage collected didn't work and someone recreated the namespace with the same name. So I'm asking, are we worried about the case when using the name podlocks, using the name of the namespace, somehow would not belong to the same namespace that after it was deleted?
I mean, namespace is a little bit, I'd have to say namespaces, I think it's a little bit buggy right now. So I think that this request seems to assume things about namespace which might not be universally true for people.
I think a perfectly valid answer can be here just to ask why this is a necessity.
Yeah.
It doesn't seem to me like rereading the issue that was actually clarified.
Yeah, okay, let's just clarify that on the issue.
Yeah.
But we do have an agenda item
yeah.
with, was it Alex and Patrick?
Yeah, we're here. This is Alex, and Patrick is also, I see him online. I think last time we attempted to present sort of the background. We ran out a little bit of time, so I just kind of want to throw it to the folks on the meeting if the background is necessary, like explaining static analysis versus dynamic analysis and why we need both, or we should just kind of like happy to answer some questions that you may have related to the CAP. Like we are flexible, so let us know how you would like us to proceed.
Well, just for context, I mean, David and I met with Alex offline, I think a couple of weeks ago, and he clarified a couple things for us, which I don't think we had fully understood. And so I thought it was kind of important that it was mentioned here so that other people are also on the same page about it.
Yeah, if you could just reiterate on that, that would be useful.
Okay, so presentation, like 10-minute introduction into this topic. Okay, perfect. Can you make me a presenter somehow?
Yeah, I'll make you co-host.
Co-host, yes. Share. All right, can you guys see the deck?
I just see a black screen.
Oh, that's not good.
I can see it.
I can see it.
Oh,
yeah, it's right, just loaded.
Okay, well, phew, that's good. All right, so just a little bit of a background. So my name is Alex Chernyakhovsky, and with me here I also have Patrick Romberg, and we are both on GT security team. And in the last year or so, we've been working on developing a solution for developing tooling to help developers catch early mistakes they make with respect to logging potentially sensitive data to logs. And in this context, we basically thought that it would be a good idea to share the tooling and sort of the expertise with the broader community, Kubernetes community, and Fairly recently, we open sourced the static analysis tool that basically is the same tooling we use internally in GKE. And how this relates to the CAP. So the CAP proposes to extend the K-log in order to analyze the objects sent to the K-logging library and find potential credentials. Let's use the term credentials, but it could be something else that we don't want to log. And there were a couple of questions. There were several good questions on the CAP in the discussion about why can't we just use static analysis? Like, obviously, it's desirable to minimize changes to the to such components like K-log, and like, what if we could just scan offline and find all the problems? And sort of the short version of this is, based on our experience, we found that at the moment, at least, the best approach is actually to use both, because that provides the best coverage. There are some certain edge cases within static analysis tooling that there are certain edge cases which are difficult to catch with the static analysis. And on the contrary, like dynamic analysis, like at the time of the runtime within K-log, are better place to detect things. So that is kind of the TLDR. The rest, I'm just kind of want to give you a little bit of a background about the static analysis. I don't know if we will do the demo just to save time. I think the demo is not particularly exciting because it just basically analyzes the source code and finds the line where we send something to log, and it prints the line where we found that error message. Sorry, we found that occurrence. So what is, like, precisely what is a static analysis, and what is it exactly? How does it work? So the type of static analysis that we are using is called a tame propagation analysis. And this is a type of dynamic analysis where with the flow of the data, potential execution flows of the data is analyzed, and we detect instances where user inputs exit the boundary of a program without being first sanitized. So in other words, like, imagine like a Kubernetes secret, or for example, token review object, which contains sensitive information, and somewhere it is initiated and it flows through the Kubernetes code base, and eventually it may hit something what we call a sink. A sink is something that takes the data and takes it outside the boundary of the process. It could be a log, it could be a HTTP call, it could be just writing to disk. So the tame propagation analysis is actually, its function is to analyze those sensitive inputs, find the places where they exit the boundary of the process, and warn the developer about the possibility that this may be an unsafe operation. Interestingly enough, this form of static analysis started out to fight the cross-site scripting attacks, where malicious users input potentially like malicious JavaScript into the web form, and then that gets saved to the database, and later on it can do some bad things when users load those pages back. So this is kind of the same principle. We basically assume that something is tainted, and we'll look for instances where it is sent to the sink. So the concept of a sanitizer, which is important again. Ideally, you want to have a library within the Kubernetes code base. Ideally, we want to have a library that knows how to sanitize things. So, like, for example, when it receives an object, it knows how to make it safe for logging. And I think essentially this is what this CAP proposes, that K-log will become this sort of library. It sort of combines two functionalities. It logs, but it also sanitizes. But obviously, as part of the implementation, we'll actually separate those two functionalities. But from the simplicity point of view, you can think of K-log becoming both sanitizer and a logger. And of course, from static analysis point of view, if we detect that the data is sanitized before it exits the boundary of the process, then that's fine. We don't have to raise any concerns there. So there's also this issue of propagators, which is very tricky. This is where things become quite tricky. Think of, for example, gRPC, so like RPC or protobuf copying. Like you take something and you convert it into a different format. Like you take, for example, a secrets object and you convert it to a string. So now the string is also tainted, right? So you need to kind of worry about those things as well. But this is just like a background that explains that there are some difficulties in static analysis as well, because you need to, it's not always the data type of the potentially sensitive object may change during its life cycle. So we'll skip the demo. We showed it last time, but I just wanted kind of to explain what is dynamic analysis. So conceptually, dynamic analysis in the context of KLX is very similar to taint propagation analysis. I think there's some noise coming from one of the attendees. If you could just mute yourself, that would be awesome. The main difference here is that the analyzer is embedded in the sink itself. So this is essentially what the CAP is proposing, to embed some sanitization logic into the K-log. Of course, this is operating at runtime. Dynamic analyzers leverage reflection and potentially you also use the call stack analysis to identify potential sources. So why do we need both? So identifying tainted data is hard. It's a hard problem. It's still under subject of active research. So therefore, we recommend for best results to use a defense and depth approach and use both static and dynamic analysis. So essentially what we are saying here is that this is the first CAP that we are proposing to solve, to mitigate the risk of logging credentials. And we will be following up with another CAP where we will propose the use of a static analysis tool as part of the pre-submit pipeline within Kubernetes. But just to keep sort of CAP actionable, we didn't want to combine those two tools in a single CAP. But I just wanted to kind of give you a background that we are certainly planning to introduce both tools into the Kubernetes ecosystem.
Yeah, so for me, that was like the key thing that was missing from it, was because the static analysis question is kind of, I guess, the obvious one that people have.
Yep.
And then basically when I understood that you had intended to do the static analysis thing and that you in fact already had code for it, I thought that was particularly relevant, especially considering that Merrick just implemented the static analysis piece for instrumentation. And so could probably give a couple pointers.
Yeah, we're already talking to Merrick, and and he was very gracious and provided a very detailed list of things we need to think about. And so yeah, this is what Patrick will be working in the coming month. But hopefully this gives you an idea that it's not one versus the other. It's really both that we need to implement for the best results. And this is just the first portion of this effort.
There's a question in the chat. Are you proposing dynamic analysis be run constantly on a production system? They're concerned about the overhead cost.
Right. It is so the dynamic analysis by definition runs at execution time, and it runs constantly. And that essentially every time there is a call to Klog, some logic will run in order to determine whether or not it is safe to log this piece of data. There are many optimization techniques that are possible, which we decided not to include in the CAP. The main ideas though there is to rely on caching. So the general idea there is that 99% of the calls will not have credentials in them. So basically, once we analyze the call site and we determine that it is not producing any credentials, then we can probably cache that fact for some time, and that will be the main idea behind optimization. Right. Yeah, but this is something we will probably best discuss like as part of the implementation on the CL, and we'll provide some benchmarks, et cetera, but it's certainly on the top of our mind with respect to how do we minimize the performance overhead.
Yeah, and just to make clear, there will be a switch which users will be able to use to switch on this functionality. And as for now, we propose to this functionality to be switched off by default. So the overhead should be really minimal in case of functionality being switched off.
Yeah, you're exactly right, Pavel. As a matter of fact, the way I look at dynamic analysis eventually, like once we mature, is that it's quite possible that that users will actually run this dynamic analysis in their testing and staging environments, and basically issue alerts when something is found, and fix the problems before they go into production. And then basically running in production, it may or may not be even something that the users need. But I think we're not quite there yet. I think not everybody at that maturity level to set up alerts and react to them at testing and staging phases.
Do you guys are you guys planning on doing some perf testing too, just in case? I mean, like I assume that like call site caching will work most of the time, but there are like some edgy scenarios where you can't really cache the call site, right?
Right, absolutely. Because yeah, we have some ideas about what performance overhead this causes. I guess my question is, what do you think would be an acceptable overhead? And I think we will just keep it in mind as we implement this. And I mean, I guess 0 probably like would 20-30 millisecond overhead be sufficient, like be acceptable? Like what do we think would be something that a community would accept?
So I think this is probably not something that we can answer, but this would be something that SIG Scalability needs to answer.
I'm sorry, who would need to answer that?
Wojciech. You should talk to Wojciech.
Okay.
Yes.
Sure.
Yeah.
Sure.
But the thing on instrumentation side, the thing that is particularly relevant is the API surface which you are expanding in Klog, right?
Right.
And particularly the filter methods or whatever, which I think is actually just generically probably very useful for us, because that basically gives us an injection mechanism, right? It's almost like layered handlers or something.
Exactly. Yeah, I agree. I think it will be a useful feature for potentially other things as well. But yeah, I think performance will become very important, and we're fully aware of that, and we are thinking very hard about how to minimize this the best we can. We will produce some numbers. I know Pavel already did some experiments, like instrumenting Klog and looking at what potential overhead that may produce. But I think it will be probably best to discuss this over CLs and benchmarks, like what's happening there.
I personally have no objection to expanding the Klog interface to add this filter mechanism, because adding layered handlers for logging could be generically useful. I don't know how everyone else feels about that. I think that's probably the most significant change from an instrumentation perspective.
Just a quick time check. I think we've got like 4 minutes left and one other agenda item.
But does anyone, David, Frederick, Merrick, how do you guys feel about?
Yeah, so I don't. I'm not particularly against this. I do think, but that's also probably because I just haven't spent enough time with Klog myself. So I would very much like us to get a review on this from Solly and Tim Hockin, because they've been quite in the weeds of the Klog v2 as well as Marek, obviously. So it's like I would like to delegate that essentially to them, and if they're comfortable with this, I'm perfectly happy with moving forward with this.
And Merrick, Merrick is like working on K-log.
Absolutely. That's that's what I added.
Yeah, definitely. I think their feedback will be useful. I think there's some ideas hanging in teams' head to like stop relying on Klog because it's starting to be a wrapper for our like customized implementations of logging. Like the current structure logging cap introduces a pluggable system for logging for JSON, and like this is the direction. This is also the interface that they designed. So I will be very interested in their feedback how this will like how this mechanism would be integrate with it. But I think this is implementation detail, and I think the overall change makes
wouldn't it make sense that wouldn't it make sense more to implement the static analysis piece first? Because since we're actively working on replacing Klog with the structured logging thing, it would almost make more sense to do the static analysis piece and then to integrate directly with structured logging as a second step if that's available, right? Like, because that could be available.
Yeah, so there are two like layers currently.
Sorry, go ahead. Sorry, go ahead, Mark.
Yeah, so currently like there are two layers. Klog currently is its own implementation and also wraps the lower level interface that we want to like go deeper and start developing. And at some point, maybe reverse those. So Klog would not be a default implementation. It would be one of deployment implementations. But yeah, like whatever, like Klog already, like it should be pretty easy to already like integrate one of those. It just depends how much work we want to do like now or postpone to future, depending on how much people want to work on removing Klog, which I don't think there's like, deprecation in Kubernetes doesn't go too fast, let's say.
Just I know we have 1 minute. I just want to throw one thought. Why the sequence? You can certainly do it the other way around. We can start with the static analysis and do dynamic analysis later. But what we found from our experience, that dynamic analysis was finding things. Basically, the challenge with static analysis is knowing the types that contain credentials. What we found is by using dynamic analysis, we were learning about the system, about the types that actually produce credentials. And that would feed basically it's a kind of a feedback loop. We find something with the dynamic analysis and we extend the configuration of the static analysis to know, hey, this type here can also contain PI. So for that reason, sometimes it's better, it may be better to do the dynamic analysis first and then ensure that static analysis has the appropriate configuration.
Well, from a safety perspective, static analysis has no performance cost. So you can introduce a static analysis that does very little, and no one's going to object to it because it runs in pre-commit.
Correct.
It's like there's no blockers. Like you just, and it's super easy to do. Like it's like
Yeah, Patrick already running it on his workstation. We actually already found one bug and fixed it. So we're already doing this. It's you're absolutely right. It's something that like we can just do it. Like no, we don't even need to ask. Like it would be nice to do it every submit, but we are running it on a regular basis, and we find something we report it. I think. But do you think it has a relevance on this cap? Like, do you think it changes anything in what this cap proposes? The order of implementation.
Yes, because mostly I think everyone was wondering about the static analysis during this cap. So like if the static analysis question was answered, then basically you'd be like, oh yeah, we already have the static analysis. We're supplementing this, and then explain the dynamic interactions between the two. As opposed to we're doing this dynamic analysis thing first, but it's like there's some performance cost. So I mean, yeah, that's how I think of things, and possibly other people may go through that cycle of thought. But I mean, if you're doing both, it's like great. I think
Right.
that sounds great.
Right. It's a good question. You know, we actually haven't thought deeply about this, but just somehow historically, that's how we started with dynamic analysis, and then we introduced static analysis. But yeah, I don't think there is a hard dependency on the order here.
I think we're out of time. Thanks everyone, and especially the presenters today. And we'll see everyone next week.
All right.
Yeah.
Thank you.
And yeah, the proposal looks good to me, and you know, I'm okay with it if the luck can sign off on it, whatever. So.
Well, thank you so much for your time. It was very nice talking to you guys. Well, hopefully we can make forward on this. Really appreciate your feedback.
Yeah.
Thanks.
Thanks everyone.
Bye.
Stay safe.
Have a good one.
Bye.
Thank you.
Thanks everyone. Bye.